Hello, this is Mrs. Jacobs, and I'll be doing a video for fourth grade GOMath Chapter 6. So we are currently mixing Chapter 5 and Chapter 6 lessons as per the parent letter that came home in the Dropbox. Okay, so if you read the parent letter, the school home letter, it's in our Dropbox. It will tell you our pacing for chapters 5 and 6 and how we will be jumping from chapter 6 to chapter 5 because lessons work better that way and the children will understand things more completely. So this video is for lesson 6.1 and 6.2, which are both on equivalent fractions. 6.1 is on drawing models and modeling equivalent fractions, and 6.2 is using more computational, strategies and tricks. So I will be showing you multiple different ways to generate equivalent fractions, as well as to determine if two fractions are equivalent. Okay, so that's our teaching point today is I can generate equivalent fractions as well as determine if two fractions are equivalent. And this is a fourth grade standards and it's for number sense of fractions. And this is standard 1 in fractions. So we will begin. Okay, so first I will be showing you how we can use or draw a model to represent an equivalent fraction. So currently we see a rectangle that is cut into two equal pieces, which is important. And one part of the two is shaded. So the fraction is 1/2 because 1 out of 2 is shaded yellow. Okay, so when we're being asked to draw a model, especially, or use a model, we always have to make sure that the model we're using is the same size and the same shape. So I would have to compare a rectangle of the same size to the rectangle of the same size. So you can't have a rectangle in a circle. So that's the most important thing is when you're drawing or using models, they have to be the same shape, same size. So here I have 1/2 and they're asking me to use the model that's drawn to represent a fraction that is equivalent to 1/2. So I notice that this rectangle is cut into 4 equal parts. And now I need to shade the same amount on my rectangle that is in fourths. So I'm just going to pick up a pen and quickly shade in that it is, if I shade in 1 out of the 4, okay, I notice that the shaded parts are not equal. Okay, so actually 1/4 is not enough. So 1/4 is less than 1/2, right? So right now I need to make it equivalent, equal to. So that's very important because equivalent means equal. So they have to represent the same amount. Even though our fractions will be different, the same amount is shaded. So I'm going to continue and do another 4th. Just shading quickly, okay? So now I see that my rectangle here is now shaded the same amount as my 1/2 rectangle. But I notice that since my model is cut into fourths, I see that 2 are shaded. So that becomes 2 out of 4 parts are shaded yellow. So that's 2/4. Okay, and if I was continue this, right, and maybe draw another rectangle of the same size, I would be using maybe 6ths, all right, and then I would be shading enough on the 6th to be equal to 1/2. which would be 3, okay? So sometimes you might be asked to use a model or draw a model. So this is using a model to help find an equivalent fraction. Okay, so here it says draw an equivalent fraction model for the model below. So first thing is I see this model below, and it's a rectangle that is cut into 4 equal parts. And I notice that 3 are shaded yellow. So this fraction model represents 3/4. So I'm just writing that, okay? So they're asking me to draw an equivalent fraction model that is equal to 3/4. So again, remembering anytime I want to draw a model, I have to use the same shape. So if this is a rectangle, I'm using a rectangle, and I have to draw it the same size. So I'm going to try my best, really, to use the rectangle that's here to help me. So I will draw it in red. Okay. So I'm going to extend right off of this rectangle. I'm going to go all the way across and come back up so that I am creating another rectangle underneath it, like a fraction strip, okay? And what I'm going to do is I'm actually going to clone, yes, clone, this exact rectangle that I see. So yes, I'm going to cut it into the same fourths. So I'm just going to replicate it, right? And yes, I'm going to shade in the 3. I'm just going to do it in a different color so that we can see it. Okay, so I'll do green. All right, so I'm still shading in. So I actually cloned it, right? So now it still says 3/4. Now, 3/4 is equal to 3/4. I need to show a model that is equivalent using a different numerator and a different denominator. So now that I have this cloned example, I have to think of a way that I can make an equivalent fraction from this model. So what I can do is I can cut this in half. So by doing that, I no longer have 4 equal parts. I have 1, 2, 3, 4, 5, 6, 7, 8. I have now 8 equal parts. And that's my denominator. And I go back and I look how many of those 8 are shaded. So I count 1, 2, 3, 4, 5, 6. So 6 is shaded green. Okay. So now I have 6/8. So 3/4 is equivalent or equal to, and this is how we write equal to, 6/8. And I did that using and drawing a model. So I used the model, I drew a model, and it shows that 3/4 is equal to 6/8. Okay. So find equivalent fractions using multiplication. So now we learned that we could do models, draw models. Now we're going to use actual multiplication to help us generate and find equivalent fractions. So I'm going to read this rule, and this rule is really important, okay? And every time I want to generate an equivalent fraction or tell whether a fraction is equivalent, I'm going to fall back on my multiplication skills, okay? So to find an equivalent fraction, multiply the numerator and the denominator by the same number. We usually start with the number 2. So this is telling us in order to create or find an equivalent fraction, we have to multiply, and that's the operation. We're going to be using multiplication, but we have to make sure that we're multiplying the numerator and the denominator by the same number. So if I multiply the numerator by 2, I have to multiply the denominator by 2. And there's a reason why we start with the number 2, is because if I multiplied by the number 1, I would get 1/3 again. And I need a fraction that's equivalent using different numerators and denominators. So that's why we always start with 2. So let me show you how that's done. So I have 1/3. And now the rule says I need to multiply the numerator and the denominator by the same number, which is the number 2. So I'm going to go ahead and do that. So I'm going to multiply the numerator by 2 and the denominator by 2. And by doing this, I will create an equivalent fraction. So I have to do my multiplication going across. So 1 times 2 is 2. 3 times 2 is 6. So 1/3 is equal to 2/6. Okay. Now, let's say we needed more than one equivalent fraction, right? So now I have 1/3 is equal to 2/6. Okay. I could take 1/3 again and now not multiply by 2. To find an equivalent fraction, I can now do multiply by 3, and that will give me another equivalent fraction to 1/3. So I will now multiply my numerator and my denominator by 3. And I will get 3/9. So 1/3 is also equal to 3/9. And I can continue this because even if I needed another equivalent fraction, I could do times 4. So let's try that. I'm just cloning. All right, and so we're going to do 1/3, and now I'm going to multiply the numerator and denominator by 4. Okay. And I get 4/12. So 1/3 is equal to 4/12. And I'm just going to make a list of all the equivalent fractions. So I have 1/3, 2/6, 3/9, and 4/12. And we'll talk about patterns of equivalent fractions in a few minutes. All right, so to find an equivalent fraction, multiply the numerator and the denominator by the same number. We usually start with the number 2, then we go to 3. We usually go in order, and we can go on and on and on, right? So this is another way to find or generate an equivalent fraction. Okay, so here I have a fraction, 2/5, and we're going to talk about another strategy which can be used, okay, is using patterns. And equivalent fractions do have patterns within them. So by looking at the numerator and the denominator, I can use multiples or skip counting to help me generate equivalent fractions. Even though teachers, right, would prefer you to use the multiplication method, there is another method which I'm about to show you, which is patterns. But you can also use this to help you check your work. So this is a really cool strategy. All right, so if I want something to be equivalent and equal, it makes sense to do multiples of that number. So since my numerator is 2, I'm going to do the multiples of 2, or as you might know, skip counting by 2's, okay? Just for my numerators. Since I have a 2, I'm skip counting by 2. So if that's a 2, the next one is a 4. After that is 6. So 2, 4, 6, 8, 10. Okay? And I'm going to draw my fraction bar to separate my numerators and my denominators. So now I look at the denominator and I'm going to be doing the multiples of 5, or skip counting by 5, which is the 5 times tables, right? So if I already have 5, I know this is 10, 15, 20, 25. Okay? And what I know about each of these fractions is that they're all equal to one another. Okay? And they all equal 2/5. All these fractions all equal 2/5. Okay? And when we get on to future lessons in fractions called simplest form, you'll see how this strategy can also help us, right? So this helps us for a lot of different things. So now I just generated 4 different equivalent fractions for 2/5 using patterns, okay? Oop, I think I skipped a slide. Okay, so now the question is, how can we determine if 2 fractions are equivalent, okay? So it says use equal, what's the equal sign, or not equal. And if you see this equal sign, it has like a slash through it, right? So that means no, and you'll see some street signs, right? That put a slash through things, and that means it's not allowed. So we have an equal sign and then an equal sign with a slash through it, which means not equal. So I'm looking at 2/5 and 4/10. And since I learned that strategy, there's 2 strategies, the multiplication one and also the skip counting one, right? But I'm going to use the multiplication one because that's the best way that we can show our work, all right? So I'm thinking, how do I know if 2/5 is equal to or not equal to 4/10? So I'm going to use multiplication. And I know that that rule said that if I want to create an equivalent fraction, I can multiply the numerator and the denominator by the same number. And it's usually to start with the number 2. So I'm going to do that. I'm going to test it out. So I'm going to go over to 2/5 and I'm going to multiply the numerator and the denominator by 2 and see if it equals 4/10. If it does, then we're in business. It's equal. If it doesn't, then it's not equal. So let me go ahead and do the work. So I'm just going to write like times 2 times 2. And then I go 2 times 2 is 4. So far we're good. But you have to check the denominator. It has to work for both. It can't just work for the numerator or just to the denominator. It has to be for both. So 2 times 2 is 4. Good. 5 times 2 is 10. Yes. So we can say that 2/5 is equal to 4/10. Okay. So now we're going to do the next one. So I'm thinking, all right, so how do I get from 1 to 2? And why I'm saying that, those are the numerators, right? So how do I get from 1 to 2? Well, I know 1 times 2 is 2, so I'm going to try times 2. 1 times 2 is 2, that's good. So I'm going to do 8 times 2. 8 times 2 is 16, but this denominator says 12. So this is not equal. Not equal. Okay? All right. So this one is a little bit different. 5/15 and 1/3. And I'm going to tell you why. Because these numerators and denominators are getting lower. I'm starting at a 5 and I'm going down to 1. And I'm starting with a 15 and I'm going down to a 3. Okay? And when we want numbers to get lower, right, we use not multiplication. We use division. okay? But if this is too confusing for you, rewrite it. You can rewrite it, and I'm going to show you both ways, okay? Or if you can handle it and you know that the numerators and the denominator is getting lower, right? We're going from a 5 to a 1 and a 15 to a 3. You could say, all right, I'm going to use division, all right? So 5 divided by what will give me 1? Well, 5 divided by 5 will give me 1. So if I'm going to divide by the same number for the numerator, I have to use the same number for my denominator. So I'm going to do 15 divided by 5, and that is 3. It does work out. So I'm going to say they're equal. But let's just say if the division part is too confusing for you, you just need to switch these fractions over. This is what I mean. Write 1/3 over here and 5/15 over here, and then we could try multiplication. Now, in this case, you wouldn't use the number 2 because 1 times 2 is not 5. So you actually have to think 1 times what number will give me 5, right? And 1 times 5 is 5. So if I multiply the numerator by 5, I have to multiply the denominator by 5, and 3 times 5 is 15. So yes, this is equal, okay? Okay, so this is how we determine if two fractions are equivalent. And again, this is one way, all right? So we could use multiplication or division, right, to help us out, okay? And next, we're going to look at a trick, okay? So we can also use the butterfly trick so that we can cross multiply. This is a trick, not a strategy, so you may use this on multiple choice questions only. By the way, you can use this for comparing fractions as well, all right? And this trick, and why it's called a trick, is because there's not that much mathematical thinking on the fraction part. It's just working, it's a trick with numbers, okay? So yes, can this help you on multiple choice questions where you don't have to show work that much or explain? Yes, but if you have to open response and show your work and then write an answer on the answer line or explain how you found an equivalent fraction, you wouldn't use this, okay? So let me go ahead and show you the butterfly trick, also known as cross multiplication, okay? So I'm going to talk it through as I draw my butterfly. So what we mean about cross is you're crossing, like an X, like crisscross. So what I'm going to do is I'm crossing and putting them into one part of my butterfly, okay, which is the 6 and the 10. So that's what we mean cross. And the word multiply is because we're going to cross and multiply those. But let's finish. So now we have to, okay, so you can see it's starting to look like butterfly wings, right? And then what we're going to do is draw a little antenna. Okay, my little antenna. And so now here comes the part, like we already crossed, right? And now we have to multiply. So how are we multiplying? We're multiplying exactly what we circled together. So here I'm doing, I'll put a little X on my butterfly in the middle. All right, so I'm going to do 10 times 6 is, and I'm going to try to write really small, but you won't see it. So I might have to go a little out of my antenna, okay? So I have 10 times 6 is 60. And then on this way, it's 8 times 8, which is 64. And now it goes to comparing whole numbers. is 60 equal to 64? And we know that it's not. So this is not equal. So it's not equal. So then I'm going to rewrite it and write 6/8 is not equal to 8/10. Not equal. And the reason why I said this can be used for fractions, comparing them, is because I have 60 and 64. So which one is greater, 60 or 64? The 64 is. So that's the greater fraction. All right. So we will get to comparing fractions later on, but we could see that 6/8 is not equal to 8/10. So it's not equal to. That is the butterfly trick. Only to be used on multiple choice questions, right? Or if you have forgotten on the multiple choice any of those other methods like multiplication or division. Okay, so of course you can play this back at any time and rewatch it, okay, how I did any of these methods. But now it's your turn, okay? So I would like you to copy and answer these 3 questions in your math notebook. All right, so first question says, write 2 equivalent fractions for 3/4 using multiplication. So I'm telling you the method I want you to use, multiplication, and I want 2 equivalent fractions, and 3/4 is not one of them. You have to come up with 2 different equivalent fractions that are equal to 3/4, okay? Number 2, you have to draw an equivalent fraction model for the model below. So I gave you a model, okay? You have to look at what fraction that model represents. And then you have to draw a model that's equivalent to that, okay? All right. And lastly, question number 3 says, tell whether the following fractions are equivalent. Make sure to show your work. So if we're showing work, I don't want you to use the butterfly trick. However, you can use the multiplication method or division method, or whichever one works for you, and then check it with the butterfly method. I truly suggest that, checking work with the butterfly trick. All right? So thank you for joining me today, and look forward to speaking to you soon.